This is continuing lesson 10. This will be what we're going to call day 4, but I think it might only be the third day of homework. But we'll call it day 4. Today we're going to learn how to complete the square. And to do that, we're going to complete the square here. We're going to solve by completing the square. So we're going to learn how to complete the square. Now, maybe before we do these problems, if I asked you to do this, take x plus a squared, would you guys say that's a perfect square binomial?
No.
Or it's a square binomial, sorry to say? It's a binomial squared. And you guys could handle that by squaring it, aka separating and, 4-letter F word, FOIL it. Okay, so you guys, I'm hoping, would understand or agree that x plus a squared would just be x plus a times x plus a. Would you guys agree?
Absolutely. Yeah.
And you can FOIL first, outside, inside, last. And if I do that, I end up with x squared plus an ax plus another ax, yeah?
Yeah.
And then a times a is a squared. I'm hoping I don't go too fast there. It's like, hey, everybody, I've done this a million times now. And of course, I can gather up the middle. And I have 2ax plus a squared. Would you guys agree that is the same thing as x plus a squared? Just copying the here down to here because they're all the same. Everybody's with me so far?
Yes.
Okay. What if I wanted to go from here to there? What if I wanted to say, hey, could I complete the square? Could I find a value of a squared that if I factored one of these guys, it ends up being x plus a squared? I'm trying to avoid having to use the diamond method or use the method of, hey, what are the factors of c that add up to b, all of those things. All those different factoring techniques that we've learned. Shortcut. Make it go faster. Maybe enjoy it a little bit more. Anytime we think something takes a long time, we think it's, oh, this is horrible. If it goes a little bit quicker, maybe it's better. Now, so look here. I have an x squared plus 28x plus something. I want, number one, find the value that completes the square, and then I want you to write it as a perfect square. That's a perfect square. I'm given an x value. I'm given a b value, a bx value. I need to find a squared. Wait a minute. I'm going to pick this up right here, and I'm going to rewrite it underneath my trinomial up here. That's a trinomial. This name right here, guys, does anybody know the name of that trinomial? Perfect square trinomial. And if I can realize I have a perfect square trinomial, I can write it as a square binomial. So, x squared plus 2ax plus a squared. Just wrote it underneath. Do we see anything in common? What do they have in common? They have x squareds in common, yes?
Yes.
What else do they have in common?
2x.
Just an x in common. So you're saying that there are things that are in corresponding parts. And if things are in corresponding parts, shouldn't they be congruent? If we're trying to say that they are the same? So can you guys realize or see that 28 and 2a are in the same exact spot?
Yeah.
So that means they must be equal. So 28 equals 2a. Could you find a? Oh, what's a?
14.
Divide by 2. It's 14. Is a used again in that trinomial?
Yeah.
Where? At the very end. It says what?
Squared.
So, wait a minute. Should I write that then as 14 squared?
Yes.
And that 14 squared actually does have a value. Does anybody remember what it is? What's 14 times 14?
140.
100. Actually, I'm not going to put it there. I'll put it up here. 190.
196.
196. First of all, it's 4 times 4, so it has to end in a 6, right? Because 4 times 4 is 16. It's 196. So if I wanted to find the value that completes the square, the answer is 196. But I got to rewrite that as a perfect square as well. Hey, wait a minute, guys. We just completed this guy right here. So now I'm going to rewrite this thing here, just for fun. X squared plus 28x plus 196. I should be able to write it as x plus what? A. Wait a minute, don't I know A?
We do.
What's A?
14.
14. And so x plus 14 squared is the perfect square, while x squared plus 28x plus 196 is the perfect square trinomial. I completed the square, and I was able to write it as a perfect square without having to factor. The number was already there. Wait, where did 14 come from? The 28. What did I do to it? I divided it by 2. So half of 28 gave me 14. Then I took that and I squared it to get 196. So I took half of b and squared it. That's what I did. Now, before we get into number 2 there, I think we probably should do another one of these with a little bit nicer numbers. Guys? Give me a second. Okay, guys. I got x squared minus 16x plus something. Please complete that square and then write it as a perfect square trinomial. Or, sorry, perfect square binomial. Or a perfect square. Okay, what's B? What's B, guys? What is B?
B is, wait, hold on. Chill.
What is B?
B.
What's the B value of this quadratic?
16.
It's not 16, it's
16x.
shh. It's negative 16.
Oh, it's a negative.
B is negative 16. To find the C value, I needed to do what with that negative 16? Divide by 2, which makes it negative 8. Guess what I'm going to do? I'm going to put negative 8, and then I'm going to square it. I'm putting it there. Or maybe, let's back this up. Maybe for these problems, I should put it underneath, because what the value I'm looking for is really negative times negative, 8 times 8. It's 64. The reason, guys, that I want you guys to write that negative 8 squared is because I got to write this thing as a square. I need to write it this way. And the cool thing is that value right there drops in. So it becomes x minus 8 squared. Done.
Easy.
Whatever b is, take half of it, square it. That's what you are adding there.
Easy money.
But to factor it, it's just x minus half of b. Done. Squared, obviously. Yeah. Now I'd like you guys to do number 2. M squared minus 1/8 m plus something. Do the exact same thing. Now we have fractions. I cannot fraction bust. Do not multiply everything by 8. First of all, it's not an equation. I cannot do that. You would change it. We want a to be 1, as in the thing in front of the variable squared. I want that to be a 1. 1m squared. 1x squared. Okay? Guys, what's another thing? Instead of saying divide by 2, what else can I do?
Multiply.
Multiply by the reciprocal, which is multiply by 1/2. So, what is b? It's a negative 1/8. So half of a negative 1/8. I don't want to do it because when you divide by fraction, you got to flip and multiply. Wouldn't it be easier to think of it as negative 1/8 times 1/2? 1 times 1
1.
and 2 times 8. So that is the value, but that is the value that's being squared. So actually right now it's probably easier to tell me what the perfect square is. What's the perfect square?
M minus 1/16.
M minus 1/16, all of it squared. Boom. We still have to find that number, but remember when you square a fraction, you square the
Top and bottom.
top and bottom. What's negative 1 squared?
Oh, negative 1.
No. 1.
Oh.
16 squared, 16 times 16?
256.
256. So there's my number that completes it. 1 over 256. And the perfect square binomial ends up being the quantity m minus 1/16 squared. Are there any questions on how to set that up?
No.
Okay. Now we're moving on. Now we are actually going to solve equations by completing the square. Guys, we're going to be solving quadratics. We can solve quadratics a couple different ways. We can bring everything to one side and you can factor it. That was really good times. But they didn't always work. Then we found out that, hey, somebody has this thing called the quadratic formula, and it always works, right?
Yeah.
We could graph them as well, but we also can do something called completing the square. If we complete the square, it goes pretty quick. The quadratic formula, guys, is completing the square. It's just that somebody did all the calculations for you, and you're memorizing the order to do it in. Like 1/2 b is part of the quadratic formula. You guys remember that?
Yeah.
It's there. So there's different things that we'll have. So there are 6 steps that I have here. And these steps may have sub-steps in there that we've done in the past. Number 1, I want you to separate your variables from all else. Sometimes, like in our problems before, they're in x's. Sometimes it's m's. Sometimes it's y's. I want you to separate anything that has a y in it, whether it's y, y squared, x, x squared, m, m squared, from everything else. So usually the constant, the number goes to the other side. 2, I want you to make sure a equals 1. And if not, you got to make it 1. So then you will divide by whatever a is. So if it's 5x squared, you will divide both sides by 5. You have to make a equal 1. It will sometimes result in fractions. Deal with it. 3, now we actually are going to do what we just did and add half of b squared to both sides. There's a twist to that. Notice that when we went to factor it, it was really easy if I left it as the actual half of b, and then I squared it on the outside. We'll keep that in mind. You're going to factor the side that has the variables, simplify the other, and then we're going to solve. Square root both sides, don't forget your plus or minus, and then you can solve for whatever the variable is. So if it's x left there, subtract 4 from both sides, or add 6 to both sides, and you're done. So we're going to use these 6 steps to solve, bless you, to solve our quadratics. Our first problem is x squared plus 10x plus 30 equals 9. So again, we have options. I could bring the 9 to the left side, and then we could try to factor that. Sometimes that'll work, sometimes it won't. I could use the quadratic formula at that point. I could graph the left side, the right side, and look for where they intersect. I could bring the 9 over and graph it and find my zeros. Or we can just complete the square. And step number 1 said, separate. There are some x's, and then there's some non-x's, right? So I'm going to take 30 and bring it over. To do that, I will subtract 30. X squared plus 10x equals what? Negative 21. Mr. Konchak, why did you just leave this large area here? Because in step 2, what does it say to do? Make sure A equals 1. Does A equal 1?
Yes.
I already saw that. And so step 2 says make sure it's 1. It's already 1. Step 3 said do what? Add something to both sides. So guess what I did? I left that space so that I can add something to both sides. Correct.
21.
And what am I adding to both sides?
21.
Half of b squared. B is, so half of 10 is
Squared.
5 squared. I'm leaving it this time in the space 5 squared. But on the other side, where I have my numbers, I will actually multiply it out or square it and get 25. Because step 4 said what now?
Simplify.
Simplify one side and factor the other. Well, I think everybody would agree this is the side I'm going to factor. And when it factors into a perfect square, which becomes x plus 5 squared.
Oh.
It's what we just did on our first exercise, right? Equals, what's negative 21 plus 25? 4. Everybody with me?
Yes.
If you're not, please speak up.
Will it always be like the simpler version like that?
Yes. Guys, we leave it as half of b squared here because that answer just gets dropped in. Right there.
Always.
Always. It's basically, we set it up as a perfect square. So therefore, it always turns out to be that way. Now, to get rid of a square, I take the square root, but don't forget, plus or minus when you're square rooting, solving for a variable. Those cancel out. You're left with x plus 5 equals plus or minus 2. The very last step said solve for the variable. Well, how do I get x by itself? Subtract 5. Very important. Everybody, listen to me. When you're doing this, and you're subtracting the 5 or adding 6 or whatever it's going to be, always, always move it out front. So that means I am placing it in front of the plus or minus. These are gone. So I end up with x equals negative 5 plus or minus 2. There are 2 answers. You cannot combine the 2 and the negative 5 and leave a plus or minus in front. Negative 5 and 2 are nice numbers. I think most of us would agree. So therefore, one answer is negative 5 plus 2. The other answer is negative 5 minus 2. And what's negative 5 plus 2? Negative 3. And negative 5 minus 2? Negative 7. We had two answers. How do I know if I'm right? Plug them back in. Plug them both separately. Plug in, bless you, negative 3 in for both of these x's. You should get left-hand side equals the right-hand side. Works. This method is like the quadratic formula, as in it always works if you do it right. There's two answers. There could be one answer, or there could be no real solution. You'll get eyes. You have to poke them out. So, bless you. Digest this a little bit, and then look at 8a squared minus 16a minus 56 equals 8. Give that one a shot. So, first thing I need to do is add 56. Add 56 to both sides. What do I get? 8a squared minus 16a equals 64. Notice I did not leave a space because a was not equal to 1. So I'm going to go through and divide both sides by 8. So I get a squared minus, bless you, 2a plus something equals, what's 64 divided by 8?
16.
8 plus something. Okay, so we got a blank on each side. Now we can actually complete the square. What are we adding to both sides?
Hold up.
Negative 1 squared. So it's negative 1 squared. But negative 1 squared is 1.
So that's not.
Right? Are you guys agreeing with me or not?
Wait, no, I am not. I'm confused.
Now we start to simplify. The left-hand side will become what?
9.
Left-hand side, not right-hand.
A plus 1 squared.
It's not a plus 1. It's minus 1 because the value inside the parentheses here was negative. Squared equals 9. Then I'm going to do what?
Square it.
Not square it.
I mean,
Square root. Don't forget
plus or minus 9.
plus or minus. These cancel each other. A minus 1 equals plus or minus 3. Going to move the 1 to the other side, so I'm going to add it, but where am I going to place it? In the front. So it's 1 plus 3 and 1 minus 3, or 4 and negative 2. Two answers. We're happy. Check them. They work. Homework, Lesson 10, Day 4, page 81, 12 through 14, and problem 21. Have a fantastic day.